In this video, we're going to do some work with vectors. We're going to work through a range of different questions and look at some of the key concepts underpinning each. In question 1, it says in the quadrilateral, the vector AB, the vector BC and the vector CD are represented by the vectors B, C and D. We need to find in terms of B, C and D, the vector AC, the vector AD and the vector BD. If we just consider AC, I want to go from A to C. Now, given the roots I've got, which is B and C, I'd simply go from A to B plus B to C. This gives me now the resultant vector AC. And if we were to write this out, we could write now that the vector AC was equal now to the vector AB plus now the vector BC. And our resultant now is going to be this line right here. It's not about the distance you've travelled, it's about the displacement from this point A. So we might have gone a long way round, but we're going to get to C. So what I can say now, using the notation given, the vector AC is going to be equal to B plus C. You're simply following the path. In the book, these are written in bold. Generally, we write them with a line underneath to show their vectors. So all we're going to have is B plus C. So that now is the vector AC. If I wanted the vector AD, well, I know a route I could take, given these vectors, is A to B, B to C and C to D. So I could now say that the vector AD would be equal now to the vector B plus the vector C plus the vector D. And this would give me now the resultant, which is AD. Okay, if we wanted B to D, well, we can go from B to C and C to D. So on the next one, we can say now that the vector BD is simply going to be now C, the vector C, plus D. So the resultant of now, so let's write this out, B to D is going to be now B to C, which we know, plus now C to D. Now I've gone round each time. In some questions, you might use previous answers. Okay. In the second question, it says the vector AB is 2, 3. This is what we call column form. A vector has both magnitude and direction. So this one right here is going 2 to the right and 3 up. The vector BC is 3, 5. It's going 3 to the right and 5 up. We need to calculate AC in bracket form. AC is the resultant vector. So we see now that that is going to be AB plus BC is going to give us now AC. So all we're doing is adding these two. So it's going to be 2, 3 and then plus 3, 5. And that will give me 2 plus 3 is 5 and then 3 plus 5 is 8. What I want to do is look at this now geometrically to see what's going on. So what I'm going to do, I'm going to draw now vector B. That was AB. So what we've got then, we're on this one now, we're going, as we can see here, across 2, right 2 and up 3. So if I drew that vector, I'd be going across 2, right 2 and up 3. So that is the vector now B. And I could show this as a directed line segment. We can show the direction by having a little arrow on it, and we'd have now B. We can show that that is 2, 3. Now consider if we were asked for the magnitude or the modulus or the length of that, we'd use Pythagoras. We'd have 2 squared plus 3 squared square rooted. Now that is the vector B. These have magnitude and direction. So if I drew one of equal magnitude but in the opposite direction, remember magnitude is just size. So from here, if I went this way, this would now be minus B. And we could show that like so. And that would be left 2 and down 3. So be careful now, these have now a direction to them. On the next one, we saw that C, the vector C, and I'll do it in a different colour, that one went across now by 3. So let's have a look. We want to go back that way. There we go. Went across 3 and up 5. So this went right by 3 and up by 5. So that now is the vector C. So let's put some information on this one. So this now is a directed line segment. We would put C on here, and in column form now this is 3, 5. When we add vectors, we add them tip to tail. So if I wanted the resultant of B plus C, I would simply now put C tip to tail like so. So let's grab that up and I could put it just here. Now this one is going to go right 3 and up 5, and we end up now with a resultant vector. This isn't brilliant to see because what we've got here now is a very, very shallow triangle right here. But that's what we've got. When we add the two, the resultant now is going to be this vector right here. And I'll put that on. It's going to be this one. Now, if we look at that, that ultimately is where we're going to end up after our journey. So, if we consider what we've got, we know that this is going to be 3, 5, and we know that we've already got the 2, 3. If I add those two, I'm going to end up now with right 5 and up 8. Now let's just check that resultant. If I go now right 5 and up 8, that takes me there. And this is what we call the triangle law. So in general, if I had two vectors and I wanted the resultant, i.e. I wanted to add them tip to tail, if I had one like so, and then I had another one that was like this, the resultant now would be the third length of that triangle just there, and that's the resultant. So for example, now if I had two vectors, and let's just label these up, if I had now a vector, and let's call this one E and this one F, the resultant now right now would be this one just here, and that would be the vector E plus the vector F. So all it's done is gone up now. So we've gone here, this particular one, E, is going to be 3, 1. F is going to be now 1, 2. So the resultant is going to be 4, 3. And we can see quite clearly that is the case. So when you add in these vectors, that's what's happening. So straight off we can see now in bracket form or column form, these are called column vectors, that's what we'd have. Okay, we need to express AB plus BC plus CD. So these are all vectors in its simplest form. Well, what's the resultant vector? If I go from A to B, B to C, C to D, that is just now A to D, and that's the vector AD. That's what we call the resultant. You'll see these link each other, B, B, C, C, so we're ultimately going from A to D. So nice and logical, nice and straightforward, and hopefully the geometric representation will show you how these work. So this one is C, and then if we were going the other way now, let's put a different one on there, this now would be minus C. So if we were coming down back the other way, a vector parallel, but in the opposite direction, we would now have minus C. And we can put that on like so, minus 3, minus 5. Okay, let's move on and look at another question. OABC is a parallelogram. If the vector OA is equal to 4A and the vector OC is equal to 4C, find in terms of A and C, A, the vector AC, B, the vector AP, where P is the midpoint of AC, and now C, the vector OP. Okay, let's work with this now. I'm being told that this is a parallelogram. Whenever I'm dealing with a problem like this, I want to label up everything I know. If this is a parallelogram, what I can now place on here is that this, being parallel to this one and of same length, that too will be 4C. So if we wanted to look at that now back on the grid, let's say I had the line now and this was the vector. Say that vector down the bottom was this one, and we were told that that was now 4C. Okay, then if I have a parallelogram, so that's 4C, and my parallelogram is sitting above that, this one too right here, or here, however we want it, will be again 4C. So all I'm going to do is write on that those are going to be equal. In the same way, what we're going to have here, if I drew two vectors like that and that, those two are parallel and of equal magnitude. So I think on this particular one, these are going, right, so they're going upwards, that's fine. So this is going to be 4A, and this too will be 4A. And in the exam, if you're doing an exam, you can go ahead and write those on. So this one, with its direction included, will be 4A. So we want to find now A to C. Now, I can get from A to C by going from A to O. O is the origin, and then O to C. So right here, I'm going to write that vector journey. Now, it might seem slightly unnecessary to keep writing this out, but it's just getting used now to what's actually going on here. So A to C is equal to A to O plus now O to C. And especially when you're doing proofs, it's important to show this. So what we can say then, therefore, this is going to be now, I want to get from A to O. It's not 4A, it's minus 4A, as we're going in the opposite direction. I'm not going to write a line under these each time, but that is something that you should do, as stated in the last part. Then I'm going to go from O to C. Well, that's going to be plus 4C. Many students at this stage write that this is 4A. Remember, it has a direction. You're going against the tide. Okay, at this stage, I'm going to factor this and just tidy this up. And I'm going to write this as 4C minus A. The reason I'm doing this now is if we look at any parallel vector, it will be some multiple of C minus A. And this is what we call a scalar. So this just essentially makes it bigger or smaller. Okay, in part B, we need to find AP, the vector AP. P is the midpoint of AC. Now, the midpoint of AC is going to be just here. Now, if this is a midpoint, all we need to do here is half this answer. So what we can say then is the vector AP, and we'll write it here, will be equal to, and I'm going to write this like so, 1/2 AC. And again, this is more formal notation. So what we're going to have is half of this. And if you wanted, you could write it. I think this is unnecessary, but you could do that. You should simply be able to state, though, that essentially it's going to be 2 lots of C minus A. If it's halfway now from A to P and P to C, then it's going to be half that vector. It will now be parallel. Just consider that resultant vector on the first part we found is this one. That's what we've done by going minus 4A plus 4C. So if we're just doing half of that, we can cut that off. Okay, so we want O to P. So if we consider now O to P, we can go a couple of different ways. The way I'm going to think about this now, knowing what I know, I can say, and this is one way you can do it, O to P will be equal to O to A plus now A to P. So all I'm doing is building up a journey. I know that A to P is 2, the quantity C minus A. So what I'm going to have then is the following. I'm building this up, and essentially what I'm doing here is going, and I'll just show you how I'm doing this. I'm going from, don't want that, I want that. I'm going up here. Once I get to A, I know how to get to P, so I'm just going to go across like so. So what I'm going to do is just write that. So I've said to myself, O to P is equal to O to A plus A to P. Well, we know that O to A is 4A. I'm given that. A to P is now 2 lots of C minus A. So what I can say now is the following. O to P, that is going to give me 4A minus 2A is going to be 2A plus 2C. So all I've done now is expanded these out and subtracted them. Or 2A plus C. And that now gives me OP. Okay, in part D it says if X is the midpoint of CB and PX, find PX. So if X is the midpoint of CB, so let's put that on. Let's put X there. So X is going to be just here. Okay, so X is going to be just here. We need to find now P to X. Okay, well consider that this is essentially in the middle. So all we're doing is just looking at this vector right here. This, if this is in the middle, is going to simply be half of this vector right here. And that's going to be now 2C. So all we need to do is write down that that's 2C. We're now in part E asked what is the geometrical relationship between PX and OC. Okay, well what we can now do is look at parallel vectors. From this, the properties of the parallelogram quite clearly tell me that. Now, if you wanted to, you could go ahead and show this, and we could prove this. But essentially, we know, given the properties, we can simply write down now 2C. So what's a geometrical relationship between PX and OC? Well, let's look at PX. PX, we know, is going to be 2C. We know that OC is going to be equal to 4C. These now are parallel vectors. So if I go back to my grid, let's say that I just represented now a vector. And I'm going to give this, let's just put that there. Let's just call this vector now, and we'll have this now, and this will be a unit vector, so it's got length 1. In fact, let's just make that look a bit tidier. If this was the vector, and let's just call this now vector G, okay? If this was vector G, then what I could do above it now is draw 2G. 2G is in the same direction, it's parallel, It's just now got a length twice as long. So this right now would be 2 lots of G. I could have 3 lots of G. Because consider now that this is 1, 0. This is 2, 0. And this one is going to be 3, 0. These are just parallel. In the same way, these would be parallel. So I could do another vector parallel to this one right here. So let's grab up a different colour. And if I did now a vector parallel, let's grab this one up. So that's what we should have. Now if I extended this and made it double the length, then I could say that that was going to be 2 lots of C. So I would come down and let's get that nice and parallel. And that therefore is 2C. These have the same direction. Parallel vectors have the same direction, just some have a larger distance or a greater magnitude. And we can see these are parallel, and now OC is twice PX. So we can say parallel, and we can say now that OC is equal to 2PX. And that's nice and straightforward and fairly logical. So geometrical relationship, straightforward, they are parallel. With this one, I've just gone for that. You might again want to show it if it's in an exam. Okay, let's move on and look at another typical question. We've got now, it says in the triangle OAB, OA is 6A, the vector OB is 9B, the point P is on AB such that AP is 1/2 PB. We need to find in terms of A and B, the vector AB, the vector AP, and the vector OP. Okay, let's draw this up. Now, our drawing doesn't have to be too accurate. We can have something that looks, give or take, like so. So what I'm going to have then is the following. O is generally given as the origin. So if I have now, let's say I put O here, and I'm going to put A here. I'm going to put B here. So what we can see now is that this vector right here, and I'm going to give this now the direction, and this is going to be 6A. We've also got now O to B, which is going to be 9B. So that's what we have. We have 6A, and then, in fact, let's just scribble that out. That doesn't look too neat. We've got now 9B. Okay, so let's do that. And we'll just jot that down. So here is 9. Let's see if I do a better job. There we go, 9B. Right, so we've got the point here, AP, and it's 1/2 of PB. A to P is 1/2 P to B. So if I put this point on here, what we can do is put now P just here. So consider that this is in a ratio now of 1 to 2. Or, if we like, this is split up into 3 parts. We're told A to P is 1/2 the distance of P to B. So it's in a 1 to 2 ratio. So what we first want now is the vector AB. So the vector AB, I'm going to come down this way and then go this way. So I'm going to write here now, AB is equal to AO plus OB. So now I can write that's going to be, and we're going to have minus 6A. Remember, I'm coming down this way. Minus 6A plus 9B. Now I'm going to tidy this up and factor it. I always like to factor these because later on it looks like we're going to have some multiples of these. So I'm going to take now the common factor of 3 out, and I'm going to write this as 3B minus 2A. So that's my vector AB. So now we want A to P. Well, if we consider now that this ratio is 1 to 2, we can say the following. We can say A to P will be equal to 1/3 A to B. In the same way we could say, and I'll just write it here, P to B will be equal to 2/3 A to B. So all I'm considering now are simply, I'm splitting this line up. AP, this distance right here, is half of the distance from P to B. So that's in a ratio of 1 part to 2 parts. So there are my 2 parts just here to 1. So let's consider now A to P. Well, that's going to be 1/3 of A to B. Now, quite clearly, I've already got A to B here. So we can say now that A to P will be equal now to 1/3 of 3 lots of 3B minus 2A, which is going to work out really nicely. So we can say that A to P will be equal now to simply 3B minus 2A. 1/3 of that is just going to give me this right here. Okay, if I want to go now from O to P, consider what I'm going to have. I'm going to have now O to A plus A to P. So I want O to P, which is going to give me now O to A now plus A to P. So all I need to do is simply take this answer and add 6A on. So I'm going to have 6A plus now 3B minus 2A. So what's that going to give me? 4A plus 3B. So that will give me now 4A plus 3B. So all I'm doing is looking at adding all of that up. Right, let's do another one. We're told OABC is a triangle with point C halfway along OB. So there it is. That looks a bit wonky, but I'm assuming it's just a printing error. Okay, so OA, the vector OA is A. That's fine. And AB, the vector AB is B. We need to find in terms of A and B, O to B. Well, O to B quite clearly is O to A plus A to B. So let's write that one in. We can say now the vector OB will be equal to OA plus now AB. So we're going to get now A plus B. So nice and straightforward. O to C, well, we know that this is going to be, we can say that O to C will be equal to 1/2 now O to B. So I'm going to write that. Now, again, you might think that this is slightly unnecessary, but essentially what I'm doing is looking at getting now these parallel vectors or multiples of one another. So it's going to be 1/2 of quantity A plus B. Now, you could write that as half A plus half B. Now, what we want to do is get from A to C. Now, if we consider A to C, I need to go from A to O plus O to C. So what I can say then is A to C will be equal to A to O, that's the vector AO, plus now O to C. I've already built this journey up O to C just here, and that's the idea now that when you write these out, you can simply add them. Now, we know that A to O is going to be minus A, as O to A is A, so we're going to have now minus A plus 1/2, and then we'll have A plus B. So if we consider now, I've got 1/2 A plus 1/2 B minus A, which is going to leave me now 1/2 B minus 1/2 A, or we could write 1/2 B minus A, and that's one way that you could do it. So again, all you're doing is looking at straightforward problems, given that this is half distance. Let's look at another question. We're told A, B, C, D, E, F is a regular hexagon with centre O. Vector OA is A and the vector OB is B. We need to express in terms of A and B the vectors OD, OE, DA, BC, OC and CF. Whenever I've got a problem like this, I like to just label this up. So what I'm going to do is simply put these on. Now what we've got here, we're being told now that the vector OA is A. Now if I just draw that vector right here, that is going to be this one here. So that is going to give me now A. So let's put that on. And what we can see is the following. So this is going to be now the vector A. It has now a direction and a magnitude. What I'm going to now do is consider all of the other ones that are A. Now this is going to be A. C to B is A. If I consider now this one here, this too is going to be A. And then finally, if I put another one on down here, D to O will also be A. So what I'm now doing is adding the other vectors of equal magnitude and direction, and just labeling those up. We know if this is regular, I can just simply apply this. Now we're told that OB is B, so what I'm going to do is put this on. So what in fact I'll put, let's just put that there as well, so that shows like that. So what we can do now is the following. We're told that O to B is B, so I'm going to put that one on. I'm going to have one just here. I'm going to have exactly the same just here, I'm going to have the same just here, and I'm going to have the same just here. So all I'm going to do from this point is simply build up journeys. So let's go ahead and put these on. This one now is going to be B. And again, you can put these now with a little line under them to show in your work the vectors. That's B, and that's B. So let's consider now O to D. Well, I want to go from O to D, so we can say then that O to D is simply minus A. You can go whichever way round you want and you will end up exactly where you want to be. but it will give you the same answer. Remember, these aren't the distance travelled, it's simply now a displacement vector. O to E, well, OT is going this way, which is going to be now minus B. If you want to think about this now from OT is minus B, let's say I didn't go that way. A minus B plus A. That means those A's are going to cancel out and we're going to have minus B. D to A. Well, I want to go from D to O plus O to A, so that is now going to be 2A. If I wanted B to C, well, B to C is going to be down this way, so that's going to be now minus A. I'm simply using the properties of a regular hexagon. O to C, well, I can go this way and down, or I can go this way and down. It does not matter. Minus B plus, B minus A. I'll get that right in the end. So minus A plus B, or B minus A. So OC is going to be B minus A. C to F. So we want to go from here right the way up, and you can do it a few different ways. So we can see now, and I'll just draw this one out as it's our last one. Let's just do that. So I'm going to go from C to F. So I'm going to go from C to D, I'm going to go from D to A, and I'm going to go from A to F. Now, if you wanted, you could have built that up from previous journeys. But as we can see from here, what I'm going to end up with is the following. Minus B plus 2A minus another B, which is going to be 2A minus 2B, or if we like, 2 the quantity A minus B. So all we've done is moved in that form right there, and that's just one of the ways that you could express that resultant vector. Okay, in the next question it says if the vector AB is 3A and the vector CD is 6A, write down the geometrical relationship between AB and CD. They're parallel. So now all I've got is one twice the size of the other. So say I drew up now, let's do this one, this is AB, then the other one is going to be parallel but double the length. So what we can say now, let's put this on, we'll put some information on this. We can say now that this is going to be now 3A, and this one is going to be 6A. Same direction, different size or magnitude. Okay, what is the geometrical relationship between vectors 4A plus 2B and 6A plus 3B? Again, let's factor these. If I take a common factor of 2 out of this one, that leaves me 2A plus B. If I take a common factor of 3 out of this one, I've got 3, and then we've got 2A plus B. We can see now that these are simply now multiples of one another. These two are parallel. So parallel now. So you can see from here that one is a scalar multiple of the other. In the next question, we're told OAB is a triangle with point X halfway along OA and Y halfway along OB. If the vector OA is 2A and the vector OB is 2B, find in terms of A and B the vector AB, the vector XY, and part C, show that XY is parallel to AB. Okay, let's go ahead and label this up then. So what we've got then is the vector now, O to A. So what we've got then, if O to A is 2A, then what I can say now is the following. O to A is 2A, X is the midpoint, so this now is going to be A, and this is going to be A. That splits this line in two. Okay, O to B is going to be 2B. So if Y splits this in half, what we can say is that this is going to be B, and this is going to be B. We first want the vector AB. So we can see now the vector AB is going to be A to O plus O to B. So we can now write that the vector AB is equal to A to O plus now O to B. If we didn't have this, we could simply now write O to A is minus 2A. So if you're given OA is 2A, then A to O is minus 2A. Hopefully I've just said that right rather than repeating the same thing. So A to B is going to be equal now to minus 2A plus 2B. So I've gone minus A plus B plus B. So I'm going to write this now as AB, the vector AB is going to be 2B minus A, and I've just factored that. So that's what we've got. Okay, if we now look at XY, let's write down XY. What we're going to have for XY, we're going to have now X to O, and then we're going to have plus O to Y. Let's consider this. If I go from X to O, I'm going to have minus A. If I go from O to Y, I'm going to have plus b. So what we can say is the following. We can say that now xy, the vector xy, is going to be now b minus a. Now what I'm going to do is put this as one lot of b minus a. So what we need to do is show that xy is parallel to now AB. So what I can say is the following. I can say that AB, now the vector AB will be equal to 2 the vector xy. Just consider now, this is just now a multiple of it. These two are parallel. Those two vectors, now that I've factored them, one is just a scalar multiple of the other, and we can show that by factoring. So if you need to show a parallel vector, just factor it and write it as a scalar multiple. Okay, let's finish with one more. And it says in a rectangle ABCD, vector AB is A, vector BC is B. Find in terms of A and B the vectors AC and BD. If you're ever stuck with this, a quick sketch should sort you out. So what we'll do, we'll quickly sketch this up. In fact, let's change the colour of that. That looks awful. And we'll work through this one. Let's just change that now to, let's go for a white, and we'll make that. So there we go. That'll do. So what I can do, I can label this up any way that I like. And I can say now, as long as these are in sequence, I can say that that's A, that's B, that's C, and that's D. Now this is a rectangle. We're told now that AB, which is this one right here, will be A. We're told BC, which will be that one, will be B. Therefore, now I can say that DC is also going to be A, and I can say that AD will also be B. So what we want then is the vector AC. The vector AC is simply going to be now the vector AB plus now the vector BC. Or if you like, you just want to go this way, it's going to be A plus B. Now we could have gone the other way. I could have gone to get to it round the other way. I could have gone A to D, D to C. I've just done it alphabetically as it's fairly straightforward. Okay, if we do now B to D, let's go from B to D. Got two choices. B to D is going to be now B to A and then A to D. Or we can go from B to C and C to D. It really doesn't matter. Because this is a rectangle now, I can use these properties and show whoever's marking it, I know what I'm doing. So that's going to be B to C plus now C to D. So what we're going to have then is B, and then this is going to be minus A. So nice and straightforward, and that's our answer. So there we go, about half an hour's work on vectors, looking at how we can deal with them. And hopefully that's been of some use. In a later video, I'll do some more challenging exam-style questions. But as stated, hopefully I'll send you away with enough information such that you can tackle these in terms of parallel vectors, the magnitude of vectors, and simply working with these basic ones here.